get a little tiny bump in that. Now, because this was so close to your y-axis, it was almost impossible to see. But as soon as you see that it jumps the asymptote, you know you got a point where it's got to come back up again. So if it's below here, you have a minimum. If it jumped it the other way and went this way and jumped, you have a maximum. And I think we did a maximum. I think we did a maximum the other day. We had a maximum, or maybe we did a minimum. I think we did both, but one of them was really, really obvious. And if you changed your window, you could really, really see the bump in it. Now, this one, even if you change your window, you're not even going to see it. But you can tell by your table. I'm at a disadvantage because I can't get my calculator up today. But if you graph this guy, you could actually look at your table. I shouldn't, over here, if this was the case, and this was going like this, I should never get a y that's negative down here. But yet, if I go to these x's, I have negative y's, which has to mean that I have to cross over that horizontal asymptote. So what you want to do is a minimum in here. Just like give yourself space to do a minimum. You'll find it. Look how, where's my minimum? Look how small this was on the y. It was really, really small. This is not a question I would ask you on a test. This is a question that I'd like you to learn how to investigate. This is like it is a precalc honors question, because this one had all possible things that you could do in here. It had a point of discontinuity. It had a min and a max. It had increasing, decreasing, which I have to put in my increasing, decreasing. I have to take it out. The range, it had a lot of things going on in here. Now, again, first step through, factor. If you didn't do this, I want everybody writing this down. You're going to factor this. Factor. Don't cross them out yet. Go to your denominator. Find a zero in your denominator. These are things you cannot use at all, whether they're an asymptote or a point. You still can't use them. Find your domain. Then, factor. And I'm going to give you that sheet when you take the quiz of all the things that you need to look for. I will give you that sheet. Factor. This point that you can reduce out of here is called the point of discontinuity. And this is why. If you remove it from your denominator, your calculator just told you where your problems were. You could go look in your table. You could see the error there. You took 4 out of your domain. You took 4 out because you can't use it. So if you remove it, where did it go? It didn't become an asymptote. It became one little point that you couldn't use. A removable point. That as our graph approaches from either end, we can actually find a point that we would be able to remove it. Now, here's a little hint also, and I wish I had my calculator. If you put this entire thing in your y1, and then you reduce this, and your reduced format, you put in your y2, it will look exactly the same. And it should. All we did was remove the point of discontinuity. And if you look at your graph, when x is 4, you will actually see your entire point of discontinuity. So why don't you try that for me? Why don't you put this guy original in your y1, this reduced format in your y2. You're going to have to do this because I have no table. I have no calculator here. My calculator is just not coming up today. Not behaving. Okay, just do a Zoom 6, do a regular Zoom 6. It should look something like this, and it does it really an injustice because Because it is so close to this line, you barely see a curve in here. But before you even put the second one in, go to your table. Look at your negatives like x5, -5, -6. What are your values of y? Positives or negatives? Negatives. Doesn't it show you that it jumped over? Don't you see that it jumped the horizontal asymptote? You may not see it in your calculator by looking at the graph because the graph can't show it. It's too exact. And we're gonna change your graph in a minute. In your y2, put this one, your reduced one in there. It should be the same exact graph. Isn't it the same exact graph? Now, do this. Go to your table. Pull it down and let's look at these values. Let's look at the 0, the 3, and the 4. In your original graph, the 0 is an error. Well, it's also an error in your new graph because it's still there. The 3 was an error. Yeah, it was a domain error, and it's still there. It's still in your new graph. It's an error. But look at 4. 4 was an error here. Yeah, it was a domain restriction. But in the second one, it has a value, doesn't it? Isn't it 1.5? Because if you remove it, it's a point that's removable, that your graph can trace right over. It's this little open circle that your graph just said, okay, let me remove it and get it out of there, which you did. You removed it when you factored this out. So now it filled it right in. This is a really good way to check your point of discontinuity. Remember I showed you by your value? I don't normally like to show you guys this one, just put the second one in, because I don't want you putting your second one in because you'll never see your point of discontinuity. You always have to put your original one in. But this will just show you that, where did this point go? It became a removable point. A point that I'm just going to jump over this part, but I technically could remove it because I approach this way and this way to the same point. Okay? Now, in terms of finding these little guys over here, this little piece over here, you might want to change your window. And on your y, go from -2 to +2. If you do that, you can see your line go below the x-axis, but you still can't see the dip like we did before. But you know there has to be a minimum there. So do a minimum from back here and let it go to here, and it will find your minimum point. It will find it. It's a very, very small point. It's very close to your y-axis, which is why you can't see it. Whenever we changed the windows, we said if you need to narrow down something to see that little jump, narrow it down, because it can jump over. So see if you guys can find your mins and your maxes with this one. See if you can find them. Can you find your mins and your maxes? Your min has to be there somewhere. It doesn't look like it is. Stephanie, do you have your sheet out working on this? That would be a really good thing to do. For those of you, I know Morgana wasn't here, Christian and Will, you weren't here. We really just went over this point of discontinuity. Each day we probably added another little thing. What did we do the day before? The slant asymptote. We did that. Were you here for the slant? You weren't here for the slant. For the point of discontinuity, we added in a slant asymptote. We added in. If it has a horizontal, it doesn't have a slant, so we had to come back and focus on your point of discontinuity. All right. right, so let's just see if we can get through this one. Were you able to find your minimum? Have to help me, guys, because I don't have my calculator ready up here. Did everybody find this minimum? So try it. Do a calc min, bring it all the way up here, bring your cursor all the way back up here, and see if you get that minimum. Did you get it, Raven?
I was
Going to the end? You don't have to go that far. But you know it's got to be kind of close where it jumps over. Usually it's like within like a couple of ticks to that. You should be able to find that minimum. You should be able to find your max. This is your max. Remember, your calculator really doesn't injustice by looking at it. You may have to look at your table to see where it's going. Yep, that'd be it. And the reason we know it had a minimum is because when we look at your table, it went from the positive y's to the negative y's. It jumped over it. But it has to come back and behave. It has to follow it and behave. Now, everything else we do goes from this reduced one. Your x-intercept, zeros of your numerator. After we reduce, there's your x-intercept, negative 2, 0. There it is right there. Your y-intercept, I didn't put my y-intercept here. Some of them didn't come out here. Now, let x equal 0. All you have to do is show me this. Let x equal 0. You've got a negative 8 in the numerator. You have a 0 in the denominator. Undefined. No y-intercept. And doesn't that show me that there's an asymptote on my y-axis? It can never cross an asymptote. A horizontal, yes, but not an asymptote. Decreasing, decreasing. You have to, your point of discontinuity. Everybody okay with their point of discontinuity? This is the removable guy. This is the guy you removed. Plug it back into the reduced one, or even look at your calculator just so that you can see where it was, and you'll find the point of discontinuity. Increasing, decreasing. Now, because you have a couple of points you have to worry about, you're going to go from left to right. This guy happens to be decreasing now. Watch. My y is decreasing till I hit this minimum point. So from x is negative infinity to that x value, I am decreasing. Then I hit that x value and my y is increasing from negative 5.162 to 0. I'm stuck at that wall there. I can't go past it. Then I have this little section right in here. I'm increasing till I reach A. So from 0 to A's point, which is 1.162. Then I decrease from there to what value? What x value? 3. That's the wall that stops me. Then here, I'm going to decrease, but I got a point that I got to jump over. I'm going to decrease from 3 to what's my point of discontinuity? 4. I'm going to just jump over it and decrease again. That's a lot of breaks there. This is probably the worst case scenario. Worst case scenario. How many of you actually found all these things? You missed the minimum? Yeah. Did you get everything but the minimum? Yeah. Okay, good. The point of discontinuity, that's the biggest concern. On the quiz tomorrow, I'm not going to throw a jump over the horizontal. It's hard. But I want you to be able to see it because these things do happen. It can jump a horizontal. And your concavity, we probably have to change your concavity here. You have a concave down right in here. This was a nice one. You have a concave up in here. However, from negative infinity to 0, that's fine. We can leave that one. And then a concave up in here, but you got to jump over your point of discontinuity. Okay? This is a tough one. But you should all be able to do probably 85% of it. Maybe the minimum was a little difficult, which would throw off your increasing, decreasing. Your point of discontinuity, be careful because you have to take that out of your decreasing, increasing things. Questions? No? Okay. And the last one you had was what, number 6? Which one did you guys do? Number 4? Okay, 4. Okay? So you're going to graph it, and again, it jumps to horizontal. It's almost like the opposite of what we just did, isn't it? It's like if you flip the graph upside down. It would almost be the opposite. So same process. I want you to get used to the process. First thing, find the domain, factor. Factor everything, don't reduce, find your domain. Those are the things that you cannot use. Before you get rid of something, find your domain. So remember, factor, domain. Once you find your domain, then you can reduce. Third step, reduce. Take out the point of discontinuity. And if it helps, label this for later. I know for me, unless I label it or pull it aside right away, I forget about it. Because when you look at your graph, you certainly don't see it. It slides right over it. Those are still the values of x that you cannot use. Okay, so we're going to make your reduced one. From here on in, we only use your reduced one. Vertical asymptotes, zeros of your numerator. Zeros of your denominator. Vertical asymptotes, that's what's left in your factored form. Horizontal, everybody go with the horizontal? The degree in the numerator is 1 less than the degree in the denominator. Y equals 0. I like after I get my asymptotes to sketch, because it'll help you recognize where your x-intercepts are, where your y-intercepts are. It'll help you if you have a jump, because it's going to affect your increasing d. It's going to affect everything else. So put that in your calc. What I would do also, guys, is these are the pieces you said you couldn't use. Make sure they say error next to them. If you want, put this in your y2. See what your point of discontinuity looks like, because you removed it from that one. Bring back your point of discontinuity. Put it back into your reduced one. And you have no y-intercepts. You could tell them algebraically you have no y. You do have a jump here. You should see, and it probably doesn't look very good on your calculator. Again, it might just go like this and stop. Well, like this and stop. But if you look at your table of y's down here will be negative, and when you get to these, they will be positive. That means you jump. Just do an increase. Just do a max on that. Do a max and find out what your max point is. It has to come back down to the line. That's what does its end behavior. This is the opposite of what we had before, when you had the little one here. Here's a relative min. Sure you find your relative min. If you need to limit your y's at all and you want to make something a little closer, change your window. And always go back to zoom 6 at the end. or wherever you decide to go back to Zoom 6. Range, did we forget our range on the other one? I think we did. I forgot the range. Be careful of your range. Your range, in this case, watch this guy. You're coming up here. So you actually crossed over that 0. You were able to use it. So you're able to use it until that y. That y is from your point of discontinuity. That's the y that you have to take out of your range. If you left it in decimals, it's 0.067. So we come up to 1/5. We jump over it. Then we go back to this guy's y value, which is 0.08, which is 0.086 if you did with 3 decimals. And we included that point, and then we did this point here. Then we jumped over that and continued back up there. Watch your brackets. At the 1/15th, you really can't use it. It doesn't exist. At this is the point that was our maximum. We had a maximum right next to your point of discontinuity. Your point of discontinuity. Actually, right on the other side of it. Are you okay with this? It's a lot of work in one. But if you can do this, that means you're thinking this through. Okay? Now tomorrow, I'm not going to give you one that's that bad. Guys, this has a slant asymptote. How do I know it has a slant asymptote just by looking at it? It's one more, the exponent is one more in the numerator than the denominator. That tells me slant. I check my horizontal asymptote thing. It has 3 different pieces. If the degree in the numerator is less than the degree in the denominator, equal to the degree in the denominator, is greater than, then I have to check to see if I have a slant. So I know I have a slant asymptote. I can factor this guy. Sorry. That's good. Take my factors right. I can factor this, right? Can I reduce anything? No. So, I go for my domain. X minus 4 equals 0. X cannot be 4. So I take it out of my domain. Okay. Now, because there's nothing to reduce, there's no point of discontinuity here. So let's now take a look at your vertical asymptotes. Your vertical asymptotes are, where do I find them? Numerator or denominator? Denominator. I couldn't reduce anything, so it stays the same. So I have a vertical asymptote when x is equal to 4. I look at my horizontal, and we just determined we had no horizontal asymptote. But we do have a slant. So a slant says, synthetically divide this to find out what your y equals is. If this is one more, when I do y2 over y1, I end up with, x2 over x1, I end up with x1. That's my y equals mx plus b, x1. This is where I get my line from. So, we divide. Pull out your coefficients. 2, 1, 0. Get your 0. X minus 4 is equal to 0. And divide. Oops. You don't care about your remainder. The remainder I don't care about. What I do care about is the front part. And this is how easy it is. X2 over x1 is giving me an x. There's my equation of my slant asymptote. Right there. Now, when you put this in your calculator, sometimes it's helpful. Graph this in your y1, in your y2, graph your slant asymptote. If your function passes over it, then something happened. It can cross it, but it can't get stuck in it. It can cross it, but it can't get stuck in it. So you'll kind of see it right away if something's wrong. From here, build your graph. You've got an asymptote at x equals 4. And you have an asymptote at y equals x plus 7. This is also a good help when you're graphing, because sometimes you will see the bottom part and not the top, or vice versa. If you graph this, your graph is going to be in this section and in this section. It's kind of like a vertical angle type thing. It's got to be in both of those. So if you see a graph that goes like this, you got to have another graph that goes like this. It's got to be up there somewhere, or vice versa. Sometimes in your calculator you can only see one. Work on the one, then change your windows. Again, I'm at a disadvantage. I should put this in my calculator here. Can everybody get this far? Do you see the slant? The slant is not that bad. The slant probably is one of the nicer ones to do. Okay. So we got this part, and we know there's another part up there. This guy over here is going to give you what? A max or min? A relative max. This guy over here is going to give you a relative min. Okay? And this is your concavity here, concavity here. You're increasing, decreasing, decreasing, increasing. So, and your concavities. Can you find the rest of those? Can you find your x-intercepts and all of those things from there? Yeah? Okay, as long as you can find the rest from there. I'm just trying to hit some that you might not like. Let's see what else was on this page.
This one.
Yes.
For this one, I actually completed the square and the zero, so we have to do that.
I just erased it, but your zeros of your numerator. For this one you did? No. For this one? No, we set those equal to 0. This was factorable, right? Only when it's not factorable. Complete the square. Did you still get x is -5 and x is 2?
No.
Yeah, that one was factorable. If it's not factorable, you need to complete the square. Any other things you want to quick take a look at? Don't forget, if you can factor, there's a point of discontinuity. What would the factors be for this? And this? So what does that tell us? What do we have in this? Point of discontinuities. Okay, you have a point of discontinuity here. All right? What's your horizontal asymptote for this? Y equals 1. Good. What's your vertical asymptote for this? No, 2 over 2, 1 over 1. Oh, you're giving, which one are you giving me? Your horizontal? Your exponents are the same. Take your coefficients. This guy, horizontal. I'm sorry, vertical. Vertical, x equals 2. We got a point of discontinuity in here too. Do we have a slant? If you have a horizontal, you can't have a slant. Alright, so go over these guys. Tomorrow, I will give you the sheet. I will give you the sheet to use. Yes.